Welcome back. In the previous class, we have already discussed cast iron and their types. And there are cast iron basically it's an alloy of ferrous and carbon, or the carbon percentage is basically greater than 2% are generally called cast iron. And cast iron basically brittle in nature. There are 4 types, and it's a malleable cast iron, nodular cast iron, malleable, nodular cast iron, grey cast iron, and white cast iron. So these are the 4 types of grey cast iron we already discussed on the previous class. Now we are coming back to the main topic on today's class, that is basically on copper and its alloy. So copper and its alloy. Now copper and its alloy, in the first point, actually copper and its alloy, when we discuss on the copper and its alloy, there are some important point regarding and copper. Basically copper also find a wide application because of the following properties, which are noted down in the given value. So obviously it is mostly used in non-ferrous metal industries, and it's a high thermal and electrical conductivity, and the electrical conductivity of the pure copper is very much high in its purest form. Any small impurities like any others like phosphorus or any other impurities, if you add within the copper, so that brings down actually the electrical conductivity drastically. But in general, the electrical conductivity as well as high thermal conductivity will be occurs in the copper. Now the second point is it's a heavy metal. It's a heavy metal, and whose specific gravity is basically specific gravity of 8.93, and it's obviously it resists corrosion. It resists corrosions. You know that the corrosion is one important parameters in the materials, because material can failure in terms of corrosions. So if the corrosions affected within the material, so material life will be reduced. So it resists corrosion, most important point, and it's joined together by brazing. So brazing is nothing, this is we discuss on the manufacturing technology. Brazing is a welding process or joining fabrication technique that can join together, and in brazing process you can use copper to join together. Now pure copper is used in the manufacture of electrical wire, like where it is used. Actually pure copper basically used in the manufacture of electrical wire, bus, cars, transmission cables, and if you discuss on, we now discuss on different types of alloy of copper. So these are the alloy. So these are the point on a normal general point are there. Now brass is one type of alloy. It's a many important alloy, we can say that. So brass is an alloy. Now if we divide the alloy of copper, we can divide following two groups. One is copper zinc alloy, copper zinc alloy, copper zinc alloy, and there is copper tin alloy. Okay, so copper zinc alloy is basically called brass, and copper tin alloy is called bronze. Okay, now one by one we can discuss. So first of all is a brass. Now it is basically used, it is mostly used in copper zinc alloy, and this is basically fundamentally binary alloy of copper and zinc. Actually it's a copper zinc alloy. That's why copper and zinc both in percentage of 50%. Copper will be 50% and zinc will be 50% in brass. Now brass, actually various types of brass will be there because of the percentage of their chemical composition, depending on the proportion of copper and zinc. If we mix together, it can be mixed together 40 60, 60 40, or 70 30, or 30 70, like that, depending on the percentage of copper and zinc, we can divide into different types of brass also. Now if you go to the next types of alloy, that is called copper tin. Copper tin. So copper zinc alloy is basically called brass, which is a copper zinc mixture of generally 50-50% copper zinc. Now copper tin alloy basically called bronze. Bronze is a mixture of copper and tin. In that case, copper tin basically percentage of copper basically mixed with tin. Tin basically is called SN. So copper is mixed 75 to 95%. With tin, it's mixed up from 5 to 25%. They can vary it. They can vary for the percentage to percentage within the range. Now, the main property of that, corrosion resistant property, and corrosion resistant property, bronze are superior. The bronze are actually superior compared to the brass. Now, depending on the composition, the bronze can be different types of bronze, like phosphorus bronze, silicon bronze, magnesium bronze, aluminium bronze, depending on the percentage. In case of when the bronze contains phosphorus, that is called phosphorus bronze. Now if phosphorus is added within the bronze, that is called phosphorus bronze, it is okay. But what are the effect on phosphorus bronze? If you add the phosphorus, actually increase the strength. It increase the strength, and obviously ductility and soundness of the casting. Okay. Now this is phosphorus bronze. Similarly, there are some other type of bronze out there, like silicon bronze. In case of silicon bronze, the content of copper is 96%. The content of copper, that is basically 96% copper, and obviously the some percentage of silicon, like 3% of silicon and 1% of manganese are generally used. That is called basically silicon bronze. It has a good property, general corrosion resistant property, and it is used for boiler, tanks, stoves, high strength and good corrosion resistance. Okay, and there are other types of bronze. There are magnesium bronze, aluminium bronze, depending on the percentage of added, which type of element that you can add on a particular copper tin alloy. If you add manganese on a higher amount of manganese, that is called magnesium bronze. If you add aluminium within the copper tin alloy, that is called aluminium bronze. But there are some suitable advantages there of particular alloying element when you add. Now there is one more alloying element that is very much important, that is called gunmetal. Already we are familiar. Gunmetal is an alloy of copper, tin and zinc. Copper, tin and zinc. This is an alloy of copper, tin and zinc. Actually the percentage of copper is 88% of copper, 10% of tin and 2% of zinc. If we can mix together, then it will be form gun metal. Okay, actually the zinc is added to clean the metal and to increase the fluidity. You know what is fluidity actually, and it is basically used in buses, bearings and gland. Okay, now next is called Babbitt metal. Babbitt metal actually it's a tin base alloy. It's a tin base alloy. It's a tin base alloy. Okay, and its percentage of tin is 88% of tin. 88% of tin, 8% of antimony antimony, and 4% of copper. That is called Babbitt metal. Okay, and it has a soft material with a low coefficient of friction and little strength. Okay, that is called Babbitt metal. Now, next is nickel base alloy. So nickel base alloy is basically the most important nickel base alloy is Monel metal. Monel metal is an important alloy of copper and nickel. Okay, where the nickel percentage is 68% nickel are present. Okay, 29% of copper and 3% other constituent. 3% other. This is the Monel metal, and it resembles nickels in appearance. Is strong, ductile, and tough. Obviously, it's a strong, ductile, and tough. Okay, and it's a K alloy. It consists of 3% aluminium, 0.5% of titanium, 0.5% titanium, one more nickel base alloy, that is called Inconel. So Inconel basically consists of 80% of nickel, 80% of nickel, and 14% chromium, and 6% of iron. 6% of iron. That's called Inconel. And it is Inconel property is that it's basically ordinary and elevated temperatures. Actually it gives good mechanical properties. As well as when in works in normal room temperature, and elevated temperature. Okay, now next type of alloying element, nickel base alloy, that is nichrome. Nichrome is basically an alloy which consists of 65% of nickel and 15% chromium, 20% of iron are present in a nichrome. And you know that the nichrome basically used in making electrical resistance where for electrical furnace where heating elements, because of the high heating resistance. That's why nichrome wire is basically used in electrical furnaces. Okay, so these are the different types of alloy that can we discuss. We can one more revise together. So copper and base alloy, first is brass and bronze. So brass basically copper zinc alloy, bronze is copper and tin alloy, copper and zinc, copper and tin. Depending on the percentage of copper, zinc and copper, tin, then different name are there depending on the percentage of alloying element that you can add. Like if you add phosphorus, that's called phosphorus bronze. Sometimes it is called silicon bronze, sometimes it is called manganese bronze, sometimes it is called aluminium bronze, like that. And another point is the gunmetal. Gunmetal is a combination of copper, tin and zinc, which percentage is 88%, 10% and 2%. And Babbitt metal is basically tin base alloy, which percentage is 88% tin, 8% antimony and 4% copper are present. It's a Babbitt metal. And some nickel base alloy, that is Monel metal, K alloy, Inconel and nichrome. Okay, Inconel is basically used in as well as good mechanical properties as room temperature as well as high elevated temperatures. And in nichrome, you know that nichrome is basically used as a electrical wire in electrical furnaces because of high heating resistance. Now the next topic we can discuss on aluminium and its alloy. Okay, now, aluminium and its alloy, some point are written here, we can discuss on that. So aluminium and its alloy is that first point is that obviously aluminium is a non-ferrous type of important metal, actually pure metal, which has some important property like excellent electrical as well as thermal conductivity, low mass density, and low melting point. You know that the low melting point, what is the melting point of that? You know that generally it varies, but you can write down 658 degrees Celsius theoretically, and excellent corrosion resistance, no toxicity, no toxic. So these are the main important points. It's a pure aluminium. Okay, and obviously it is very soft. You know that it's a very soft. It is very soft. As it is soft, obviously it is ductile in nature, and obviously it has a high reflectivity and low emissivities. So these are the important point of the pure aluminium, and it's the source of aluminium is bauxite. So bauxite is aluminium source, and there are some aluminium alloys are named there. So duralumin, gamma alloy, magnesium, okay, indelium. So these are the different types of alloy are there. So first we discuss on duralumin. Duralumin composition is that copper is basically in the composition. Okay, copper in the composition of 3.5 to 4.5%. Copper in the percentage of copper 3.5 to 4.5 percentage, and manganese is 0.40 to 0.70 percentage, plus magnesium 0.40 to 0.70 percentage, and the remaining is aluminium, and the remaining is aluminium. So this is the chemical composition, this is the alloying element, and this alloy, actually duralumin, has a maximum strength about 400 megapascal after heat treatment and age hardening. Okay, after working, if the metal is allowed to age for 3 to 4 days, it will be hardened, and this phenomenon is called age hardening. Okay, next alloy is called gamma alloy. So gamma alloy is also one type of core called copper aluminium alloy. Copper aluminium alloy, and it is basically used, this alloy is heat treated and age hardened like duralumin, and it has a better strength than duralumin at high temperature. But duralumin has strength, but gamma alloy has a better strength compared to the duralumin, or the percentage of gamma alloy, it's so gamma alloy, so percentage of gamma alloy is basically copper of 3.2 to 4.5 percentage, manganese 1.2 to 1.7 percentage, nickel 1.8 to 2.3 percentage, and some other silicon, magnesium, iron are there. So remaining percentage is aluminium. So other type of alloying element that is called magnesium. Magnesium is basically made by melting of aluminium with 2 to 10% of magnesium. It's made by melting the aluminium, so by means of first melting the aluminium, and with mixed together 2 to 10% magnesium, this is called magnesium. Okay, and hindalium is also one type of alloy of aluminium, and magnesium also one will be present, and some small quantity of chromium in that particular, that is used, chromium, and it is basically, so magnesium is a melting of aluminium with mixed with magnesium, and hindalium is one type of alloy where the melting of aluminium that is mixed with the magnesium and chromium, that is called hindalium. Okay, and it is produced in as a roll product in 16 gauge, mainly for anodized utensil manufacturer. Okay, so these are the some alloying element of copper and aluminium. So thank you for today's class. Next class we will discuss on another topic. Okay, but